positive. If they lose, that should be a negative. So first I'm gonna go ahead and I'm gonna go ahead and make my box. So for the box, the top should always remain the same. This should always be X. This will always remain P of X. The only thing that should be changing are what you put in these boxes right here. All right. Let's figure out what to put for P of X. So for P of X, what we want to go ahead and do, we first want to just figure out what are the two different outcomes that could occur. So in this problem, the two different outcomes that could occur is either the person is going to win the lottery or the person is going to lose the lottery. So that's what we're going to put. We're going to put they could win, but they could also lose. All right. So let's go ahead and let's figure out what should be the probability of this person winning, what should be the probability of this person losing. So the key thing that they give us, they tell us how many tickets they sold. So they told us they sold 5,000 tickets. So we know the probability should be out of 5,000 because they sold 5,000 tickets. So out of the 5,000 tickets, how many of those tickets are gonna win?
Professor, did we just start?
Yes.
Okay, perfect.
So of the 5,000 tickets, so how many of them are gonna produce a winner? Well, if you kind of think about it, if they have 5,000 tickets, there's only gonna be one winner because it says the payout is $5,000. So you put 1 out of 5,000. So that's the probability of producing a winner. So if we want to find the probability of producing pretty much that they lose, is pretty much you have to kind of think about the complement. So if we only have one winner out of 5,000, then that represents that out of the, oops, sorry about that. That out of the 5,000 people, you subtract 1 and you get 4,999. So that's how many people are gonna lose. So for the probability of this person losing, it'll be 4,999 divided by 5,000. Right. Any questions so far on the probability of this person winning or this person losing? Okay, so let's go over the X value. So the X value is gonna correspond to the net winning or the net losing. So what you kind of have to understand for this one, so we're gonna start off with losing. So if the person lose, they're out $5. So if they're out $5, we're gonna put negative $5 there. So they're out that much money. So you put negative 5. So then if they win $5,000, but you have to account for how much did they have to pay to play the game or to play the lottery? They had to pay $5. So you put 5,000 minus $5, which give you 4,995. All right. And that's how you want to get the X value. So the X value for winning, it's the net profit. So you have to account for they get $5,000, but in fact, since they had to pay $5 to play the game, they technically only win $4,995. If they lose, they're just losing the $5 that they paid to play the game. So, any question in regard to how I set up the box? Okay, so the -5 come from the $5 that they had to pay to play the game. So if you pay $5 and if you lose, you're out that $5. So since you're out that $5, that way we put -$5. Okay, cool. All right. So the last thing what we have to do, we have to go ahead and multiply these values. So I'm gonna do x times p of x times p of x. So I'm actually gonna do that in my calculator, and I'll share that right now for that way you can see the calculator. So you get 4,995 multiply by 1 divided by 5,000. And then you go positive or plus a -5 times 4,999 divided by 5,000. And you get expected value is equal to -$4. And that's your final answer. All right, and that's it for part A. Any question in regard to how we did part A?
So I'm kind of confused in the sense of, so wait, we just multiply 495, which is x, 4,995, which is x, times 1/5,000, which is, okay, we just put that there, and then we add. So it's like multiplying two tops and then adding it by the bottom.
No, pretty much you're just multiplying across. So you're multiplying, if you're talking about the fraction, you're multiplying the two top numbers on the fraction. So you do 4,995 times 1, and then you divide that by 5,000. Then you get -5. You multiply that by 4,999, and you divide that by 5,000.
Okay.
Yeah, you're multiplying across. It is basic fraction multiplication.
And just to confirm from last week, this is the formula where it's the sum of all of these line items, right? If there were more lines, we would just add them.
Correct. Yeah, for this one, it's the sum of it. But since one of the line is always going to be negative, you're always going to be subtracting in the case scenario.
Got
it. So, any other questions? All right, let's do part B. All right, so let's do part B. So I'm going to go ahead and draw the box. I'm going to draw this box a little bit bigger because the last one was pretty compact. Yeah, whatever. So let's read this problem. So it says an insurance company estimate the probability of an earthquake in the next year to be 0.0013. The average damage done by the earthquake is estimated to be 60,000. If the company offer earthquake insurance for $100, what is the expected value of the policy? So if you look right here, we have expected value. So that's telling us we want to find E of X. So for this one, we want to do it for the insurance company. So for this one, we're going to do it for the insurance company. So if they have to pay out, that means they're losing money. If they don't have to pay out, that means they have to keep the money. So that's how we're going to distinguish a positive and a negative. So if you read the problem, pretty much there's two events is going to happen. Either an earthquake is going to happen or an earthquake is not going to happen. So for this portion, we'll put earthquake. And we'll put no earthquake. Any question why is earthquake and no earthquake? All right, so let's go over and let's do the probability. So the probability should be probably the simplest one to do. So let's go ahead and do that. So let's first do this probability over here. So what is the probability that earthquake would hit? What do they tell us the probability is? And you could put in the chat, or if you want, you could shout it out.
Probability is 0.0013.
Yeah, perfect, Anna. Thank you. So they tell us the probability that earthquake will hit next year is 0.0013. So that's the probability of earthquake. So if I want to find the probability that there's no earthquake, or it's pretty much just the complement of that, you have to get the probability that the earthquake is going to hit and subtract that from 1. So we're going to do 1 minus 0.0013. Let me do that on my calculator. And you get 0.9987. So if I know the probability that earthquake is going to hit is 0.0013, if I want to find the probability that earthquake is not going to hit, all you have to do is do 1 minus the probability that earthquake will occur. Any question in regard to P of X for earthquake or for no earthquake? All right, so let's go on to X. So for X, we're going to put either the profit or how much are they going to lose. So we have to kind of think about it in the eye of the insurance company, because pretty much if they have to pay out, that means they're losing that money. But if they don't have to pay out money, that means they get to keep whatever the premium is. So when would they keep the premium? When an earthquake hit or when there's no earthquake?
And keep it when there's no earthquake.
Cool. So they keep it when there's no earthquake, and in this case, the premium that they have to pay is $100. So we'll put $100, and that's a positive because that means they're gaining that money. Because essentially, if no earthquake hit, that means they get to pocket the $100 you just paid for that insurance company. Well, that insurance policy. Sorry. All right. Everybody go with the plus 100. All right. So that means they're gonna lose money when an earthquake actually does hit. Because when an earthquake hit, that means they have to pay everybody out. So if you look right here, they say it's an estimate of $60,000. So that's what we're gonna estimate the payout has to be. So they're gonna be out $60,000. But the thing is, they already collected the $100. So you have to do the net loss. So the net loss will be 100 minus the $60,000. So that will give you a negative 59,900. So this is the value that you want to use. Any question in regards to that last part? So let's go ahead and what we're gonna do, you multiply these two number, and then once you multiply those two out, you add them up. But just kind of remember for this one, since one of the number is negative and the other one is positive, you're technically gonna be subtracting them. So I'm gonna switch it over to my calculator. So that way you can see how I enter into the calculator. So first you do negative 59,900. You multiply that by the probability of that occurring, which is 0.0013. Then you add it to the 100, multiply by 0.9987. And if you multiply that out, you get positive 22. And that's it for that problem. Any question in regard to how we did that last problem? All right, so that's it for page 4. So page five is pretty much just practice. So if you are having a hard time with doing these last two problems, you do want to kind of go over the last D, C, and D. For that way you can practice on it a little bit more, how to set up the box, how to set up what X, what the P of X is. But just use these two for practice. So we're actually going to skip page number 6. So for page number 6, you don't have to worry about that. You're not going to have to find standard deviation where you have an X and P of X. So let's ignore that. And let's get into binomial. So you should be on page number 7 right now. All right. So for a binomial distribution, there are a set of thing or a set of conditions that you have to check for to see if it meet a binomial distribution. So the first thing, kind of when you look at by just mean two options. So that's what the first row is kind of alluding to. Because it said each trial must have two categories for outcome, either a success or a failure. So you always have to be able to set up where it's a success and a failure. It cannot be where it's one success, one failure, and then one other thing. You should be able to distinguish that it's a success or if it's a failure. All right. So the second condition is that they have to tell you how many times they're doing the experiment. So the experiment could be like, okay, how many times are they flipping a coin, or how many times are they selecting a random person? So they have to tell you how many people or how many objects are they randomly selecting from the get-go. If they don't tell you how many people or how many person they're randomly selecting, then it's not a binomial distribution. All right. Any question for that second condition? All right. So for the third one, it said each trial must be independent of the other. So that means it has to be done with replacement. So if you kind of remember when we did like the multiplication rule, when I talk about independent, that's what it's referring to. It means that one event or one experiment shouldn't influence the chances of the second experiment or the third experiment. Each experiment should be independent from the other. So kind of like a quick example, kind of think about like flipping a coin. When you flip the coin the first time, the probability that it will land on head is 50%. When you flip the coin the second time, the probability is still 50%. So each event or each experiment is independent from each other. All right. Any question for this third one? All right. So you do want to kind of know some notation. So P is the probability of success. So if I say P, I'm referring to probability of success. Q is probability of failure. So if you remember from the first condition, we said it had to be success or failure. So when you do success, the probability of success plus the probability of failure, it should always add up to 1 or add up to 100%, whatever you're doing. And that's what this is saying, that P plus Q should equal to 1. All right. Any question in regard to that? All right, cool. So let's get to the formula. So this part of the formula, this is the combination rule. This is what you, well, part of what you have your quiz on. So this is N, C, and they put an X instead of a R. So that's just telling us how many different combinations we could get that particular order. So if we just want to figure out the different type of way that you could get that combination, we're just going to use NC, I think in the calculator, NCR. Once you find that, you're going to get the probability of success, take it to the X power, and multiply that by the probability of failure, taken to N minus X, which this will give you how many failures.
Question. So NCX is the same as NCR?
Yeah. In this problem, the only thing that's different is that they're using X for R, but pretty much the same thing.
Okay, cool.
So what we're gonna go ahead and do, we're gonna do our very first problem for binomial. So we're gonna see how does the binomial formula work by doing this next problem. So for this one says example of how to do a binomial distribution. So find P of X is equal to 2 if X is a binomial random variable when N, with N equal to 6, P is equal to 0.3. All righty then. So this notation, they're telling us X is equal to 2. So we know X is equal to 2, we know N is equal to 6, we know P is equal to 0.3. So if P is equal to 0.3, what is Q equal to?
Point 7.
Yeah, 0.7. And the way Alan got that, you do 1 minus 0.3, which will give you 0.7. And that's how you get that 0.7 over here. All right. So we got everything that we want in order to be able to find our binomial distribution. I know what N is, I know what P is, I know what Q is, I know what X is.
Another thing is like, so you did 1 minus 0.3, and that's equal to Q. But so how is P and Q in relation to each other?
Well, pretty much if you go P plus Q is equal to 1, you subtract Q, P is equal to 1 minus Q. Or if you want, you could do minus P, and you could get Q is equal to 1 minus P.
Oh, okay. I didn't know that P plus Q is equal to 1.
Yeah, it's right over here.
Where?
Right here.
Oh, hold on. Oh, okay. I see it now.
Cool.
So what is the question asking? I'm not kind of confused. Like,
Yeah, so if you look at the question, it's asking us to find the probability. So it's asking us to find the probability when X is equal to 2.
okay. Makes sense.
So let's go ahead and do this problem. So the first part I'm going to go ahead and do, we're going to go ahead and do this. So if you remember, I told you when it has nx, that's equal to n c of x. So we already know how to do this with our TI-83 or 84. So instead of putting n we said is equal to 6. So you go 6 c. Instead of putting x, we're going to put 2. So we're going to do that in our calculator right now. But any
What is
questions?
the TI 83 over 84?
What was that?
What's the TI 83 over 84?
Oh, that's your calculator.
Oh, okay.
All right. So if you remember, to be able to do this, you first have to enter your n. So you enter n, which is 6. You click right here where it says math. You go over where it says PRB. And if you look right here, we do NCR. It's the same thing. The only thing different, instead of putting X, they put R. And then we put a 2. And we're all done. So we get 15. So for this part right here, I'm going to put 15. So we go probability X is equal to 2 is equal to 15.
So you press math and then you go PRB and CR, right?
Yes, exactly what I did. All right. Everybody get where the 15 come from? So let me kind of clean this up. All right. So if you look at the next thing, is our P. So we put P, which is 0.3. And then if you look at it, it want X, which X is 2. So you go 0.3 to the second power. So the 0.3 to the second power represents that we want 2 success. So that way we say 0.3 to the second power because we want 2 success. If you look at the next portion, say you get Q. So Q is 0.7. And then we want to put how many failures do we want, which n minus x will give us. Because if I do 6 minus 2, what's 6 minus 2? So what does 6 minus 2 give us? All right,
4.
there we go. So 6 minus 2 give us 4. So if you look at it, it's telling us we want 4 failure, but we want 2 success. And if you do 2 plus 4, that should give you 6. So it's, those 2 exponents should always add up to your n value. Because however many success plus however many failure you want should add up to n. All right, so any question? I got 15 times 0.3 to the second power times 0.7 to the fourth power. All right. So I'm gonna switch over to my calculator for that way you can see how I enter into my calculator. But then that will be it for that problem. So you do 15 multiply by 0.3, and you put 0.3 to the second power, take it out, and you multiply that by 0.7 now to the fourth power. And if you multiply that out, you get probability that x is equal to 2 is equal to 0.324 blah. And that's our final answer from that part. Any question on how we did that part? So I'm going to show you a way to double check your answer using your TI-83 or TI-84. So first thing you want to hit your second button. And then hit where it says VARS. So TI-83 or 84. All right, so you go second, you go to VARS. So, well, let me switch it over to my calculator again. So you go to second, you go to VARS. So if you scroll all the way down, if you look at it, it gives me two options. So PDF, and it also gives me CDF. So for right now, we're gonna just use PDF. So the reason we're using PDF because we only want a singular outcome. Because the singular outcome that we want is when x is equal to 2. So we only want that one outcome when x is equal to 2. That way we're gonna use a PDF right now. So I'm gonna select PDF. So for PDF, it's gonna ask you for trial, P, and X value. Trial is your n. So in this case scenario, what was our n value? Now if you want, you can put it into the chat.
6.
6, perfect. All right. What was our p value?
0.3.
Yeah, perfect. And lastly, what was our x?
2.
2, perfect. So you go right here where it says paste. For some of you, you might have this where your calculator actually tell you to enter it. So you put 6 and then you hit the comma button, which is above the 7. Then you hit 0.3 and then you put the comma again. And then you do 2, hit the comma again. And there you go. And you get exactly what we got by hand.
I have a question. So for trials, what is trials?
So trial, if you remember, I said it was for n.
Oh, okay. So I'll put n equals trials in my notes.
Yep. And
And how did you, I looked away for a second. How did you get to that portion on your calculator when you selected binom PDF?
oh, so it kind of depends on your calculator. Which calculator do you have, Anna?
TI-83 plus.
Okay. So for you, if what they call that a wizard. So you're talking about how do I get to this portion, correct?
Yeah.
So in yours doesn't have this because yours, if it just show up like this, correct? So it will just show this, correct?
Yeah. So I just missed what you were pressing to get to that. Sorry.
Okay, so like for you, what you have to do, you have to press 6, and then press comma. You do 0.3, then go comma, and then you do 2, close it, and then you just enter it.
Got it. That's what you were saying by manually entering the comma. Okay.
Correct. Because if you have the wizard once it asks you all the information, it will actually automate the comma. But if you have the TI-83, you have to just enter that. All right. Any other questions? Cool. All right. So in the test, if I just ask you to find the binomial, if I don't tell you to like upload your work or anything like that, you can use a calculator for this portion of the test. Let's move over to the